Next, we're going to learn about the pivot. Most solutions read from the initial simplex tableau don't actually produce the optimal solution. But what we can do is use matrix row operations, change all the entries in one column to be all zeros and 1, 1, and that 1 is called the pivot. So basically we're changing our initial simplex tableau to an equivalent simplex tableau, and hopefully we'll get a better solution. So that's what we're going to do first. Now, the first example, we're trying to pivot about the indicated 6 in this tableau, which is in row 1, column 2, and we want to pivot about that. So we want to make the 6 into a 1, and then all of the other values above and below it to be zeros. Now before we get too far into this, I want to mention that the initial simplex tableau, because S1, S2, and S3 only have 1s and zeros in them, right now S1, S2, S3 are my basic variables, and that means X1, X2, and X3 are my non-basic variables. Now, in the process of pivoting, that is going to change because I'm going to pivot about the 6 because the problem told me to. We are going to change X2 column to have all 1s and zeros, which is going to make another one of the basic columns have other values in it and therefore be non-basic. So we're going to change which columns are basic and non-basic to get a better solution. Okay? So the first step is to use row operations to change the 6 into a 1. So I'm going to do that by taking row 1 and multiplying it by its reciprocal and putting it back into row 1. Notice that all of the rest of the values are going to stay the same. So row 2, 3, and 4 are all going to stay the same. So I'm going to go ahead and fill that in right now. And now I'm going to go back and actually multiply the whole first row by 1/6. 3 times 1/6 is 3/6, which can reduce to a half. 6 times 1/6, or basically 6 divided by 6, is 1. 2 divided by 6, that's 2/6, or a third. 1 divided by 6 is 1/6. 0 divided by 6 is 0. 0 divided by 6 is 0. 0 divided by 6 is 0. 60 divided by 6 is 10. So I have now successfully got the 1 where the 6 was. So that is your very first step in trying to pivot about the 6. We're changing the basic and the non-basic rows. Now, we need to get the rows above and below the 1 or the pivot to be zeros. So I need to work on that. I'm going to have to make the 5 into a 0. To do that, I'm going to take the opposite of positive 5, which is negative 5, times the row with a pivot in it, which is row 1, and add it back to row 2, putting it back in row 2. So the next row 6, I'm going to do that in blue. Opposite of positive 6 is negative 6, times the row with a pivot in it, which is row 1. Add it back to row 3, put it back into row 3. And I'll do the last one in purple. So we have negative 50. The opposite of negative 50 is positive 50, times the row with a pivot in it, which is row 1. Add it back to the row 4, put it back in row 4. So I'm going to actually have to do quite a bit of work over here on the side, but I have it all color-coded, so hopefully that will help a little bit. So I'm going to take row 1 in red, multiply it by 5. So negative 5 times a half is negative 5 halves. Negative 5 times 1 is negative 5. Negative 5 times 3 is negative 5 thirds. Negative 5 times 1/6 is negative 5/6. 0 times negative 5 is 0. 0 times negative 5 is 0. 0 times negative 5 is 0. And 10 times negative 5 is negative 50. Underneath that, I am going to write row 2, and row 2 is 8, 5, 4, 0, 1, 0, 0, 80. So when I add this down, you might want to use a calculator here. Negative 5 halves plus 8 is going to be 11 halves. Negative 5 plus 5 is 0. Negative 5/3 plus 4 is going to be 7/3. Negative 5/6 plus 0 is negative 5/6. 0 plus 1 is 1. 0 plus 0 is 0. 0. And negative 50 plus 80 is 30. Now this is going to go in place of row 2. So when I use my new matrix, I still am going to keep row 1 exactly the same. Make sure you keep your spacing about the same. For row 2 in red, I'm going to replace it with 11 halves, 0, 7/3, negative 5/6, 1, 0, 0, 30. The next one in blue, negative 6 times row 1, so negative 6 times a half is negative 3. Negative 6 times 1 is negative 6. Negative 6 times 3 is negative 2. Negative 6 times 1/6 is negative 1. 0 times anything is 0, 0, 0. 10 times negative 6 is negative 60. All right, and now I'm going to put row 3 right below it. Just be careful so that you're not making any mistakes here. So when I add down, I get 0, 0. 7 minus 2 is 5. Negative 1 plus 0 is negative 1. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. And negative 60 plus 120 is 60. And so that row 3 is going to go back in my matrix. And then my third one is going to be in purple. So that's positive 50 times my first row. So that's going to be 50 times 1/2 is 25. 50 times 1 is 50. 50 times 1/3 is 50/3. 50 times 1/6 is 50/6. 50 times 0 is 0. That's 3 times. And then 50 times 10 is 500. Underneath, I'm going to put my row 4, and then add down. So this gets me negative 5, 0, and again you might want to use your calculator. 50/3 minus 15 turns out to be positive 5/3. 50 over 6, add to 0 is 56. 0 plus 0 is 0. 0 plus 1 is 1, and 500 plus 0 is 500. So we have negative 5, 0, 5/3, 56, which probably should have been reduced, but I haven't done that yet. 0, 0, 1, and 500. So looking at the columns again, and I probably could label these x1, x2, x3, s1, s2, s3, and z. At this point, what are the basic variables? So the basic variables are the ones that have all 1s and 0s. So we have a basic on S2 and S3 just like we had before. But also now the pivot column is the basic variables. So we have basic, 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 which now means that x1 is a non-basic, x3 is a non-basic, and s1 is a non-basic. So that's the very next thing that they're asking us to do here. Identify our basic variables, which are going to be x2, s2, and s3. And our non-basic are going to be x1, x3, and s1. So because I have all of those basic variables identified, what I'm going to do is I'm going to let all of the non-basic variables be equal to 0. So if I think of every single non-basic variable as 0, it's like I can put like a clean line right down the columns of my non-basic variables. Then when I read the equations from left to right, I see that I have 1 x2 plus no s2s plus no s3s plus no z's equals 10. Let's read the next one. The next equation says I have no x2s plus 1 s2 plus no s3s plus no z's equals 30. The next equation says I have no x2s plus no s2s plus 1 s3 plus no z's equals 60. And then the very last equation, when we're left to right, I have no x2s, I have no s2s, I have no s3s, but I have z equals 500. Okay, so those are my new equations if we let all of the non-basic variables be 0. So to write out that solution to all of the variables, I have x1, x2, and x3, s1, s2, and s3, and then z. Okay, so for my basic variables, I have x2 equals 10, s2 equals 30, s3 equals 60, and z equals 500. That means my non-basics are going to be x1 equals 0, x3 equals 0, and s2 equals 0. This is a feasible solution, and I want to emphasize that. This is a feasible solution. It may not be the best feasible solution, but it definitely is a feasible solution. We're going to spend the next section learning how to get the best feasible solution, but this one does work. The fact that we have s's, slack variables having values, means we're going to have some leftovers. Like in our previous example, we might have leftover acreage, or we might have leftover capital that we didn't use. We have some leftover resources. That's what the S means. But at least we have a value for Z, which we may be maximizing or minimizing. But at this point, we just have a feasible solution that we found that was different from the feasible solution of the initial simplex tableau. So this concludes our lesson on the slack variable and the pivot.